sound you just heard is called pink noise. This sound is not produced by mechanical means. Instead, it originates as a stream of electrons in a vacuum tube. Pink noise is composed of the sounds of the orchestral spectrum appearing entirely at random. What makes pink noise especially useful for test purposes is that it contains equal sound energy in each of its octave bands and possesses the impulsive character of many musical sounds. We can select any desired portion of pink noise by means of electrical filters and obtain sounds with physical properties not unlike those of musical instruments, but endowed with precisely controlled dimensions. Our initial test is intended to check the correctness of loudspeaker connections in your equipment, this being the first requirement of a good stereo system. For this purpose, we use a noise band 1/3 octave wide, placed 1 octave below the middle C, that is, at 128 cycles per second. The resulting sound resembles the rumble of a kettle drum. The tone appears first on the left loudspeaker, then on the right one, followed by a few seconds of silence. This sequence is repeated several times. Adjust the balance control until the left and the right sounds appear to be equally loud or balanced when you stand midway between the loudspeakers. If the tones are in reverse order, that is, right-left, this means that your loudspeakers are switched left for right. Correct this by interchanging the loudspeaker connections. Now, listen to the test. The next test is for channel phasing. If the channels are correctly phased, then equal signals will form virtual sound images, which will appear to emanate between the loudspeakers. If the channels are out of phase, then these virtual images will not appear. Furthermore, the loudness of bass tones will be greatly diminished. In the test which follows, we use the same 128 cycles per second noise band for which the system was balanced during our previous test. The tone is presented first in phase, then out of phase, followed by a brief silence. This sequence is repeated several times. Listen to it from a location midway between the loudspeakers. The first sound should be the stronger of the two and appear to be centrally located. The second sound should be weaker and more difficult to localize. If, however, the first sound is weak and the second one strong, then the channels are incorrectly phased. To correct this condition, the connections to any one of the loudspeakers should be reversed. Now, listen to the test. $6,000. $5,000. 4,000. 3,000. 2,000. 1,500. 800. 600. 200. 150.